Have started with the discussion of thread programming, how to create a thread and all. That is what we have discussed in the last class. So, so to create a user-defined thread, yes, all of you, this is what we did. We have defined a class and made it extend your thread class, and we have overridden this run method, and in the run method, we have written this task, right? Yes, the task for the thread is written in that run method. You see, we are calling this start method, so which will start the thread. See, you'll create a thread class object, and on that object reference, using that object reference, you'll call the start method. Yes. So once the start method is called, so it will register this thread with the thread scheduler. The start method will register this thread with the thread scheduler, I can say. Yes, that is what it does. Okay, fine. So if you don't call the start method, the thread will not execute. If you don't call the start method, the thread will not execute. Okay. Yes. So for suppose, what if I call the run method directly? What happens? Yes. If you call that run method directly, that means in this case, you'll find that the thread will not start with execution. It won't be registered with the thread scheduler. If a thread is not registered with the thread scheduler, it won't execute. If the thread is not registered with the thread scheduler, it won't execute. Okay. Then how many threads are created altogether in this case? What do people think? Yes. How many threads will be started in this case? Yes, that's right. Only two threads. One is main thread, the other one is sample thread 2. Okay. So we are calling this run method, right? So who will execute this run method? It is just like any other method call. Which thread will execute this run method? Then sample thread 1 is not created. So which thread will execute this run method? Yes. Which thread will execute this run method? Actually, in context of which thread we are calling this method, in which thread context this method is called? In the context of main thread, this method is invoked. In the context of main thread, this method is invoked. So main thread itself will execute the run method also. Main thread itself will execute this run method also. So main thread will be responsible for executing the instructions which are defined in this main method, Along with it, it also executes this run method here. Just only once that too. Only once it executes this main thread, not one. The another time, the run method will be executed by sample thread too. That's it. That is how it works. So let me run this program. You see that values 0 to 4 are printed by main method because main method is executing the run method. No? Yes, this is what happens. Okay. So I hope you people got it. Now let me just make it start here again. Now we saw one way of creating the thread. You know what? There is another way of creating the thread also. What is it? Using runnable interface. So far we created a thread by extending thread class, right? So what you can do is you can also create a thread by implementing runnable interface here. You can also create a thread by implementing runnable interface. So we have runnable interface defined in java.lang package itself. Yes. Hi Krishnaveni, we are talking about threads here. So just starting with runnable interface. So what is this runnable interface? Actually, runnable interface, you will find that it contains that run method. It has got one method, that is run method. Run method is there. And your thread class also implements this run method actually. Runnable interface, I can say. The thread class also implements this runnable interface. Yes. Okay. Now let's try to define a class using this runnable interface here. New class sample runnable. It implements runnable interface. Overrides this run method here. That's it. Override run method. So, and we'll override this method. Let me just add this statement. Thread created using runnable interface. Okay. So can I say that this class is actually, can I call it as a thread class? Can I say that this is a thread class? Can I say that this class is a thread class? No. I can say no. I can say no. Okay? Yes. Fine. So you know what? I can say that basically this class only represents the task for the thread. It only represents the task for the thread here. That's it. Okay. So let's see how to create this thread here. Test runnable. So first, now this time what you will do is here you have to instantiate this thread class. Yeah, directly you will instantiate the thread class and you will pass that sample runnable object reference as input. So what we have in the sample runnable, just now as I told you people, we got the task for the thread which is defined in the run method of the sample runnable. Yes. So now let's name this thread here. Thread dot set name sample thread. You can give any name you wish, and then we'll start the thread here. That's it. Let me start this thread. I'm sorry. Yeah. So Now first suppose here I want to create another thread which also performs the same task. What to do? Yes, if you want to create another thread with the same task, in that case, you see, actually in that case what you can do is, first of all, you can just create the sample runnable object and store it in a reference variable, sample runnable. Now this time you can pass that reference this way. Now if you want to create another thread with the same task, first create a thread object. For every thread you should have a separate thread object, okay? Yes. For every thread you should have a separate thread object. You see, while creating the second thread object, I'm passing the same runnable object reference where you have the task, because both the threads have to work with the same task, right? Yes. Both the threads have to work with the same task. Yes. So now let me give a name to the second thread. This is thread2.set name sample thread2, and then you can call the start method here. Yes. Okay. Let me start the two threads. Yes. So now which approaches do you think is better? First approach or the second approach? Yes. Which approach do you people think is better? First one or second one? Yes, by extending thread class is better or by implementing runnable class is better? Which approach do people think is better?
Implements runnable.
Implements runnable. Yes. If you use runnable interface, that would be better because what happens is here when we make a class to extend thread class, now see we're just adding a restriction. Now this class cannot extend any other class, right? That is one of the problems. Here, but in case of sample runnable, we have a chance to make this class extend some other class also. We got a chance to make this class extend some other class also. Okay, so now let's talk about thread lifecycle. So when we talk about the threads, basically thread has got a lifecycle, and a thread in its lifecycle will go through various states. What are the various states of this thread's its lifecycle? Let's see. See,
5 states.
yeah. So we have new,
Ready.
runnable, running state will be there, right?
Yes, sir. Waiting.
Dead state. Oh, sorry, sleep, wait, or log state will be there. And then dead state.
Then
Yes. So these are the various states. So here, let's talk about the states. We try to understand the states here. Yeah. First, we'll start with this new state. New state means you see, this is the state the thread is in after the thread instance has been created. Yes. After the thread instance is created, the thread is supposed said to be in new state, I can say. Yes. The thread is supposed to be in new state. Yes. Yeah. Yes. We created a thread class object in this case. So let's take this thread. Now we created a thread class object. And okay, we have assigned some name. You see, before calling the start method, I can say that basically the thread, it is in new state, I can say. It is just a thread. It's just like in any other object. That's it. Nothing more than that. It's just like any other object. You see, this is the state the thread is in after the thread instance has been created, but the start method has not yet been invoked on the thread. The start method is not yet invoked. It is a live thread object, but it is not ready for the execution. It is a live thread object, but you will find that basically it is not ready for the execution here. Yes. So next we we call the start method. Once the start method is called, what happens? So when we call the start method, now the thread, it moves from new state to runnable state. When we call the start method, the thread will move from new state to runnable state, I can say. So what is this runnable state? Let's see. Runnable state means, you see, this is the state a thread is in when it's eligible to run, but the scheduler has not selected it to be the running thread here. So when we call the start method, it becomes runnable. The state of the thread is runnable and it is eligible for execution, I can say. So the scheduler has to, if the scheduler is the thread scheduler is supposed to select this thread for execution here, but it has not yet done that. Yes. But so far, I used to say that when we call the start method, the thread will immediately start execution, right? Yes. But now I'm saying that here, the thread is not yet running. It is just waiting to be selected by the thread scheduler. Yes. Why so? Because you see, when we call the start method, the thread won't immediately start with the execution. Okay, it will register it with the thread scheduler and waits for it. It will wait for its turn because the processor, it might be busy executing the instructions of another thread. A thread can only execute when the processor is assigned to it. Please remember. So when we when we start the thread, so straight away it won't start execution. It needs processor for the execution, and processor is a busy guy, always executing the instructions of some other threads. So because as I told you people, it is 1:n ratio. The ratio between the threads and processors, you will find that it is 1:n, same as processors. Okay, every thread needs a processor, and at any given point of time, it can be assigned to only one thread, not more than one thread. Okay, so that is the reason why the thread will be in runnable state immediately after we call the start method. So it has to be selected. You see, all these things happen in a fraction of a second. Though we are talking about it, for hours, but internally how it works, it just happens in a fraction of a second. Registering the with the thread scheduler, thread scheduler selecting this thread and assigning the processor so that it can execute. Everything happens in a fraction of a second. Yes. You see, a thread first enters the runnable state when the start method is invoked, but a thread can also return to the runnable state after either running or coming from the block state. We'll talk about it later, okay? Don't worry about the second point. Next, you see, once the scheduler selects this thread for the execution, we can say that the thread is in running state. So it will move from runnable state to the running state. This is the state, you see, a thread is in when the thread scheduler selects it to be the currently executing process, I can say. Yes. So when the thread is in running state, what it will be doing, what do you people think? When the thread is in running state, what it will be doing? Maybe the question looks weird. Yeah. So what it will be doing? Yes.
So can you repeat the question?
When the thread is in runnable running state, what it will be doing, what it is doing.
The program is executing. Sometimes it will go to the waiting stage.
So when the thread is in running state, I can say that it will be executing the instructions which we have written in the run method. The thread will be executing the run method. When I say the thread is in running state, what it is doing? It is actually executing the run method, okay? So once the run method finishes the execution, once the run method finishes execution, you see, it moves from running state to the dead state, I can say. It moves from running state to the dead state. So apart from that, okay, when the thread is in running state, there are few more things which we need to consider here. What is it? You see, the thread, when it is in running state, when it is executing the instructions, so we may ask the thread, we may ask the thread to sleep for a while. We may instruct the thread to sleep for a while, okay? We may ask the thread to sleep for a while. So when we ask the thread to sleep for a while, what happens? You'll find that the thread will move from running state to the sleeping state, I can say. the thread moves from running state to the sleeping state, I can say. Yes. You know, when the thread is in sleep state, that means the thread is not executing any instructions. It is just simply sitting idle. It is just simply sitting idle. It's not executing any instructions, I can say. It is just sitting idle. You know, even the processor is not assigned to this thread now. Okay, processor will not be assigned to this thread. Yeah. Now, once that time period expires, see, we ask the thread to sleep for a while. We specify the time, right? We want the thread to sleep for a specific period of time. The thread does that. It will sleep for a while. Once the thread it comes out of the sleep state, you see, you'll find that the thread will move to the runnable state. It will move to the running state. It won't move to the running state here. So once the thread comes out of the sleep state, what it does, it will move to the runnable state from sleep state. Why it won't move to the running state from the sleep state? Once the time period expires, it won't move to the running state. Instead, it will move to the runnable state. What is the reason? What do people think? Yes. What is the reason? Because, you know, when this thread moved to the sleep state, some other thread might have been assigned the processor, and it might be the currently executing thread. When this thread comes out of the sleep state, and it has to wait for the processor again. Yes, definitely. It is supposed to wait for the processor again. Yes. That's the reason why it will move to the runnable state here. Okay. Next, we have The sleeping state already I've discussed about it. Okay. Next, dead state. You see, a thread is considered dead when the run method completes. You see, the thread, once it is done with the execution of the run method, the thread has got nothing to do, right? It is said to be dead. Once a thread is dead, it can never be brought back to life. If you invoke start method on the dead thread instance, you'll get a runtime exception. Yes. If you call the start method again on the dead instance, what happens? You'll get runtime exception. Okay. So these are the various states of a thread. So is it clear for you people, all of you? Okay, good. If it is clear, then we'll move on. Now, I'll talk about another important thing here. Let's see. Just a second, please. Sorry. So now let me show you people few things here. We'll see how multiple threads can operate on the same object, same data. Let's make multiple threads to operate on the same data. Is it possible? Yes, of course. See, let me just create a text class here. Test multi-threading. Let's see. So I'll instantiate this thread class here. First of all, sorry, I'll create a savings account class object here. Not savings account, I'm sorry. Let's define a thread first of all. So let's say account service. I'll call a thread called as account service. I'll make this class implements runnable interface. We'll define the task for the thread here. What is the task for the thread? I want the thread to read the savings account object. Okay, here let me just, I want to read that savings account object details. So for that you should have a reference to that savings account object here. The thread should have a reference to the savings account object. So what I'll do is I'll declare a variable like this here. The reference variable of type savings account, which can take that savings account object reference. We add a parameterized constructor. See, we got the constructor here. Yes. So now let's override this run method. In the run method, we got the task for the thread. So what it is supposed to do, print the details. Okay, account number, savings account, sorry, account dot account number. You can print the balance here. Okay, yes, and balance, account dot balance, get balance. That's it. Okay. So this is our thread here. Yes. You see, let's try to instantiate this class. First, I'll create a savings account object here. All of you, this is very important. We learn how threads will be operating on the objects, especially multiple threads on the same object on the same data, which leads to some issues which will be addressing them using synchronization, thread synchronization. Multi-threading is very important. Okay, so we got an object, savings account object. Now I'll create account service object which implements that runnable interface. Right, it implements that runnable interface now. Yes, new account service. pass that account savings account class object reference here. That's it. So now we are passing that account object reference. Now this account service basically it represents a savings account object, right? Account service here basically it represents savings account objects here. Yes. Okay. Now let's start the thread. Let's start the thread and we'll pass this account service object reference which contains the task for the thread here. What is the task for the thread? They have to read that account details. I'll do this. You see, thread dot set name. Say thread 1 and we'll start the thread. That's it. Okay. Now we'll start this thread and let's see what happens here. See, got this. So as of now, I hope what we did is clear. So thread is operating on this objects, right? Now I would like to create another thread, and to that thread also I would like to assign the same task. What to do? I'd like to create another thread, and to that thread also I would like to assign the same task. How can we do that? Now that thread also should operate on the same object, account object, should read the same account details. Yes. So what are we supposed to do here? So what you will do here, you have to create another thread object. Simply instantiate another thread object here. Instantiate this class. Create another thread object. Account service. Thread to dot set name. The thread name is thread 2, let's say. And then we will call this start method on the thread. That's it. Okay. Yes. Now what I'll do is here, which thread is printing this account details will try to also print the name of the thread, okay? So that you'll understand. Yes. Um, thread dot. What is the method used to fetch the object reference of a thread which is currently executing this method? I want to fetch the object reference of the thread which is currently executing this method. So what to do? What is that method which is used to fetch the object reference of the thread which is currently executing the method here?
Running.
Current thread. We have used it earlier. Current thread.
Okay.
The object reference of the thread which is currently executing the method, you can obtain it using current thread method. Current thread method returns the object reference of the thread which is currently executing the method here. Yes. Okay. Now let's see. Now we have two threads. I can say that both the threads are operating on the same object. How? Because you see that account service object, it holds the reference to the savings account object, and that account service object reference, we are passing it to both the threads here. We are passing it to both the threads. Same account object reference is passed on to both the threads here. Yes. Okay. Both the threads will have access to the same account object. Yes. See? So I hope you people got it. So anyone got any questions in this regard? Okay, good. Just a minute, please. Just a minute. Yeah, sorry. So, if multiple threads are operating on the same object, you may have issues. Okay. Yes, definitely you may come across overlapping issues, I can say. So to demonstrate this overlapping issues, I'll change this code. I'll try to, you know, intentionally produce that overlapping issue here. Okay. Yeah. You see, I'll make the threads to operate on this withdraw method. When multiple threads operate on this account objects withdraw method, here in this case, what I will do is I'll try to produce that overlapping issue. I'll try to produce that overlapping issue, I can say. Okay. Yes. So here the threads, when we instruct the threads to execute this method, you see, I'll do one thing. I'll make those threads to also print the details. Okay. I want to print the details about this activity of the thread, what it is doing. Yes. So let's try to print the activity here. You see, um, the thread will check the balance here. It will check for this balance, right? After the thread is done checking the balance, I'll make the thread to print the statement. See, thread, what is the name of the thread? Or let's say we'll print the name of the thread itself directly. Thread dot current thread dot get name is about to withdraw is about to withdraw. Okay. Yes, this is the message which I'll print. Okay. Now you'll find that it will print this message that it is about to withdraw. And then you see, before it withdraws that amount, before it deducts the balance, I'll just add a sleep method here. Let me just add a sleep method. Okay. So why I'm adding a sleep method before the thread is about to update that account balance? To just represent some activity which will take place before the thread withdraws that amount. Before the thread, it deducts that balance. You see, let's say it is supposed to take the acceptance from the users. Generally, the threads will take the acceptance from the users, right? Yes, they'll take the acceptance from the users. Yes, you know, you'll find that this, instead of writing that instructions, I'm just adding the sleep method. That's it. See, after checking the balance, let's say the thread, it wants to take a confirmation from the user. Okay, it wants to take a confirmation from the user. Yes. So, here, how it will take the confirmation from the users, maybe whatever the instructions you have, I didn't write it. That time latency, delay in time, I'm just adding it here. Okay. Yes, that's it. Next, we'll update the balance. And once the thread is done updating the balance after detecting that withdrawal amount from the balance, let's say it will print a message that thread is done withdrawing. Thread is done withdrawing. Yes. Yes. Next, here, what if the thread here, if it is not able, if that there is insufficient balance, in that case also we'll make the thread to print a message. What is that message? Let's see. So there is not enough balance for the thread to withdraw. Yes, there is not enough balance for the thread to withdraw. That is the message which will print. Okay, so this is what it prints. Fine. So now let me just define the task for the thread now. Here, the account service. This time the thread, instead of printing the account details, so it is supposed to withdraw the amount from that account. How many times? 5 times. Okay. So each time it is supposed to withdraw how much? 1000. Each time it is supposed to withdraw 1000, let's say. Okay. So you see, each time it will call this withdraw method. That is a task for the thread. It has to execute withdraw method 5 times. And after each withdrawal, we'll check the account balance also. If account balance, if it is less than 0, that means the account is overdrawn. Actually, the account is not supposed to be overdrawn, right? Yes. I'll print a message, account is overdrawn. Yes. Account is overdrawn. This is the message which I'll print. Now, let's start the first thread. I'll only start the first thread here. So what is the initial balance of the account? 5000. Okay. So when we start the thread, so it will execute this run method and it will deduct the 5000 from that account. How many times? Each time 1000, not at once. Each time 1000. Yes. So here everything should go fine without any issues. You see, it executes 5 times, I can say definitely. Withdraws that amount here. Yes. Next, you know, here I'll introduce another thread now. Now this thread, what it does, it draws the amount from the account. How many times? 5 times. Okay. It will also will draw that amount from the thread here. So altogether both the threads will execute the withdraw method 10 times, but we have only 5000 now. In aggregate, both the threads will be able to only withdraw 5000. That's it. So rest of the times the thread should not be able to withdraw that amount, right? Let's run this code. You see, have you noticed it? The account is overdrawn, but actually account is not supposed to overdraw. Account is not supposed to overdraw, right? It should not be overdrawn because e before each withdrawal we are checking for the balance and all, right? How come it is possible for the account to overdraw? Because you see, this is where the issue is. If multiple threads are operating on that object, you have this kind of overlapping issues. Though we have written the code to check for that balance amount, minimum balance, but still that account somehow it is overdrawn. Okay, yes. Why that account has been overdrawn, I'll tell you. Because both the threads are operating on that object. Okay. Now, one of the thread, let's say the account balance is 1000. Last 1000 rupees is left over in the account. Let's say thread 1 started execution, and what it does, let's say it will check for that balance. It started executing this withdraw method and it checked this balance. It finds that there is enough balance. So you see, it will print the statement. Meanwhile, account 2 or the thread 2 also may start executing this method here. So it will also check the balance. It finds that there is sufficient balance. Okay. So what happens here? You see, the thread 1, because thread 2 will also get sufficient balance because thread 1 is not yet finished with the execution, right? Yeah. So what happens here? You see, the thread 1 will go into the sleep state. Thread 2 prints this message, let's say that it is about to withdraw, and meanwhile the thread 1 comes out of the sleep state and deducts the balance. You see, thread 2 is not aware of this fact. It also goes to the sleep state, comes out of the sleep states, and it will update the balance to minus 1000. Yes. So because both the threads are operating at the same time, you see, we will have these issues. Even though we have written the code to check for that balance and all, but still you will have this issue. This is overlapping issue because multiple threads are operating on the same object. Yeah. So is it clear for you people, all of you? Yes. Is this point clear, all of you? Can I have yes, please? Or if you have any issues, please let me know. So we'll see how to address this overlapping issue. Okay. We'll see how to address this overlapping issue. So that is the next thing. This is where your synchronization comes into the picture. Yes. Okay. Yeah. So I'll talk about it in the next session. We'll see how to address this issue mainly. And we have a few more interesting things to work with here in the threads that we'll discuss in the next session. I'll stop it here today. Let's meet tomorrow and we'll continue our discussion. Yeah. Thank you all. Bye.